Okay, so this is the solution to the 31st problem in the grind 75. This one is binary tree level order traversal. And basically, given the root of a binary tree, we want to return the level order traversal of its nodes values. So we got to remember that trees are graphs, and what a level order traversal is in a tree is the same thing as a breadth first traversal in a graph. So we're going to switch over to Paint really quick. So just to remember, there's two different traversals, two common types of traversals, and there's one is called depth first, where we go down all of the children first, and then the other one is breadth first, where we go level by level. So we go over this level's nodes, and then that level's nodes, and so on. So because we're doing level by level, we're going to be using a breadth first search algorithm, and when we use a breadth first search algorithm, we're going to use a queue. And we're going to see how that works right now. So I'm just going to kind of make this our queue. And right now we're just going to worry about visiting the nodes in the proper order. So the way that this works is we start by adding our root to the queue. So we're going to add 3 to the queue. And then we're going to say, for as long as our queue is not empty, or as long as there's still values in the tree to add, we're going to start by looking at what we currently have and then iterating through that. So we're going to look at what we currently have, and we're going to start by removing it. And let's call this our results array. Say this is results, and this is just Q right here. I don't know, I used a capital Q. This is a Q. We start by adding the roots to the queue, and then we'll say for everything that's currently in the queue, we're going to start by grabbing that node. So we're going to remove it, and then we're going to look to see if it has any children and add those to the queue. We are also going to, upon removing the value, add it to our results list. So then we're going to add 9 to the queue first, because we're going to do the left child first, and then we're going to add 20 to the queue next. And then we're just going to repeat the process. For what we have in the queue currently, we are first going to pop the value that we added. First in is the first one out. Pop it, add it to our result list, add its children to the queue. So this would be 14 and 2. And then we're going to pop the next thing in our queue, add it to our results, and then add its children to the queue. So 5 and 17. And as you can see, upon the next iteration, we are simply just going to pop everything from the rest of the queue, add it to our results list, and there will be nothing more to add to the queue because its children will be empty. And again, we said while the tree is still has values in it, we're going to add to the queue. And that is the explanation. Let's dive into the code really quick. All right, now that we know how breadth first search works, let's see how we can use it to implement this problem. So we're going to go level by level, and we're going to want to create in a list for each level, and then add that list to our overarching results list. And as we can see from the example, if we have an empty tree, we're still going to want to return some sort of list. So we're going to start out by creating that list. The exact static type that they ask for, it's going to be called result, and we're just going to set it to an array list for now. All right. And then we can do that check to see if it's null. So if root is equal to null, then all we have to do is return result. Okay. from here, we can continue by adding or by creating our queue. So queue is an interface in Java. We are going to be adding those nodes into the queue, and we can just call it queue. And one class that implements it is linked list. Say not integers, tree nodes. All right, and as we said in the illustration, we're going to start by adding the root to the queue. Okay, and then while our queue is not empty, so while queue.isEmpty is false, we are going to start by getting the size of our queue. So we're going to say int size is equal to queue.size, because we want the current size of the queue, because once we start adding, then the size will change. But we know that the current size represents everything on our current level. So we're going to say that is the size, and then we're going to get our current node. So we're going to say tree node current node is equal to queue.remove. That's going to grab that node from the queue, and now we have access to it, and we can do what we want with it. So what we will eventually want to do is add it to its own list, which will represent a level. So we can say cur level is equal to, we can just maybe make that a linked list too. Doesn't really matter. It could be an array list. Just to keep memory down, we'll make it a linked list. All right. And so we're going to say for essentially for everything in our current level, or we're going to just say, well, I is less than size, we are going to let's see, we removed it. So we don't actually remove the current node until we begin iterating through our level. So at this point, we remove the node, and we can then add it to our level. So we can say current level dot add current node, and then from there we can check to see if it has any children, and if it does, then we're going to want to add it to the queue. So we're going to say if current node dot left is not null, then we're going to say queue dot add current node dot left. Similar check for the right node. If right node is not equal to null, then we're going to say queue dot add current node dot right. Okay. And let's see. So that should be good. And okay. Once we've gotten through this entire statement right here, we are going to want to add that level that we had just completed to our overarching results list. So we're going to say result.add current level. All right, and then once the queue runs out, then we've traversed every node in the tree, traversed through the entire tree, and so we can simply return result. And I believe that's all there is to it. Let's just do a quick look through of everything. All right, we seem to be good, so we're just going to hit run really quick. So what do we have? If int I, let's see what the issue is here. So it seems like we tried to make the if statement a for loop. That obviously doesn't work. And also, we want to return lists that have the nodes' values on them, not the actual nodes themselves. So let's run. Okay, passed that test, so let's submit. All right, so that has been the solution to Grind75's 31st problem. This has been binary tree level order traversal. I'll definitely come back to this when I need a refresher on BFS. And also, something that I was worried about with the whole while loop is I thought it would exit as soon as this condition is false. But as we can see, when we add our root, we pop it like almost right away or remove it, but this body continues to execute. It's only until we get to the end of the set of instructions does it check for this condition again. So just going to remember that.